Factoring the greatest common factor. This is one of the most basic types of factoring, but it's also one of the most important. If we look at example A, and we follow the guidelines in purple on the screen, we need to look at the coefficients, we need to look at the variables, and we need to look at the exponents. If we look at the coefficients, those would be 4, -2, and 8. We can see that you can divide all three of those by 2. Another way of saying that is you can factor out a 2 from each of those. If we look at the variables, we have x squared, we have x, and then we have a constant with the 8. So there's no variables that are common to all three terms, so we can ignore them for the moment. So to factor this, like we said before, there was a 2 that's common. We can take it out. So when we take out a 2, we have to open up a bracket. This is basically like the reverse of distributing. So we had 4x squared, we're dividing it by 2, so we have 2x squared left. We had minus 2x that we were dividing by 2, leaves us with minus x. And we had 8 that we're dividing by 2, leaves us with plus 4. So that expression is now factored. B is a little bit different, however. B, if we take a look, we have that bracket of 2x plus 1 showing up in both terms. This will be what's common. So if you see a bracket showing up both places, that's what's common, that's what you need to take out. So instead of just putting 2x plus 1 in front, it is a bracket, it is distributed, we need to keep it such. So 2x plus 1 was common, we take it out front. From the first term, when we took out 2x plus 1, we had a 3x left over. From the second term, we actually had 2 sets of 2x plus 1. That's what the 2x plus 1 all squared means. So not only do we have the minus 4 coefficient, but we also still have 1 set of 2x plus 1 left over. Now at this point, we need to take a look, is there any simplifying we can do? Well, yes there is. So this 2x plus 1 is going to stay at put, but we can distribute that 4 into its 2x plus 1 as such, and we can then simplify just a little bit more. 3x minus 8x gives us negative 5x, and we had the minus 4. Example C takes us into the realm of negative exponents. First, let's deal with the coefficients. 3 and negative 48, there's a 3 common that we can take out, we'll do that. Variables common to all the terms, while we have x's in both terms. But with the negative exponent, it becomes a little questionable. What do we take out? What is common? This is where we look at what is the smallest exponent found on either of those variables. Well, we have x cubed and x to the negative 1. So negative 1 is what's common to both of those terms. So when we take out the common factor, we said 3 was common to the coefficients, and x to the negative 1 was the smallest exponent that we saw. In the past, it would just be easy, subtract exponents. Still is just that easy, but we need to keep in account that we took out an x to the minus 1. So we look at our 3x cubed. We took our 3 out. 3 divided by 3 is 1. We took x to the minus 1 out. Original exponent of 3, subtract negative 1. Turns into 3 plus 1, gives us x to the 4th. Take 3 out of negative 48, we get negative 16. When we take x to the minus 1 out of x to the minus 1, negative 1 subtract negative 1 is actually negative 1 plus 1. So we have x to the 0. We don't need to write x to the 0. We can leave it right like that. Those of you thinking that you might be able to factor this a little more, yes we can. It's just going to come up in a few minutes.